Hello, greetings. This is Professor Khan, and in this week we will explain. I will explain to you Ohm's law and power law. I would like to take the time for you to have some practice problem, understand the relationship between them, and how to use those two laws. And this is going to be very useful for us when we do electrical. So these are the objectives. We will know how to use Ohm's law and how to utilize that useful tool to calculate voltage, amperage, and resistance. We will learn how to use the power law, which is a little bit different than Ohm's law. And in that law, we will calculate power, voltage, and amperage. Also, we'll understand the relationship between the two laws, the power law and Ohm's law. And by doing so, we will know how to do a simple calculation to connect both of those laws together. Okay, let's get started. So the book offers you this little formula here, which is basically a simple relationship between the two laws, and they use a circle. I like to use a triangle, and it's very simple if you just bear with me a little bit. So this is Ohm's law. Ohm's law. In the top, we put the voltage. They refer to the voltage as E. I do it as V, as voltage. And in the bottom, we'll have resistance, which is R, and amperage, which is A or I. This is like the same, it's just different notation. Okay, how do we use that law? Let's say you need to have two of these components to find the third. So from top to bottom, you divide. From side to side, you multiply. So if I want to find the voltage, you'll cover the voltage and you'll multiply the bottom. So it's going to be amperage times resistance. If I want to find the resistance, I'm going to cover the resistance, and that will be voltage over amperage. So from top to bottom, whatever unknown you have, you divide. And to find the amperage is going to be the same thing, which is voltage over resistance. And that's what they have over here. So whatever you're missing, you will go use the relation from top to bottom, top to bottom, divide, and side by side multiply. So again, if you look at the example here, we have E, which is the voltage. To calculate the voltage, you are missing the voltage, so this is what you need. So we only have the bottom component, so we multiply them together to get the voltage. And if we want to get the current, which is I or A, that's what you're looking for. So you have the voltage and you have the resistance, so you divide the voltage over the resistance. Same thing for resistance. You have the you need to find the resistance, but you have the voltage and the amperage. Okay, I left an empty slide here so I can explain this a little bit more. Again, here is the voltage, resistance, and amperage. And from top to bottom, we divide, side to side, we multiply. I will repeat that again. If I want to find the voltage, I'm going to use a highlighter. If I want to find the voltage here, I will need to have the amperage and resistance. So voltage will equal amperage times resistance. And again, these laws you can look them up, you can bring them in a note with you. You don't have to remember them, but if you remember, it's a triangle and the top is the voltage. It's easy to remember. And resistance will equal voltage divided by amperage, and amperage will equal voltage times resistance. So very simple, right? It's not going to be complicated, and this what we will use is just how to utilize them and defining the relationship between those three components. And every circuit will require you to have voltage, resistance, and amperage. Okay, the second law is the power law. Again, it looks the same, but this time power is in the top, voltage in the bottom, and amperage. There is no resistance here. The same rule goes. From top to bottom you divide, side to side you multiply. Power is the rate which electrons do work. This is, again, we said power is the spending of energy. They are measured in watts, so the unit here is watts, amperage is amps, and voltage is volts. Easy. So the formula power equal voltage times amperage. How so? If I want to find the power here, I have the bottom components, so I just multiply them together. There are other units for power, which is horsepower or conversion between watts and BTU. And usually if you look at your electric bill, they charge you with the kilowatt. So kilo is 1,000. So it's 1,000 watt. Why? Because it gets a little bit bigger. So instead of saying 200,000 watts, you can say 200 kilowatts. Just makes a little bit things a little bit easier to read and interpret. Okay, moving on. Electric energy, it's the rate at which the power is being used at specific time. We said that already. Here are the power law relationship with other formulas. You don't worry yourself about this formula. It has the square root and power. It's a little bit complicated. If you have the two laws side by side, one is the voltage here, that's Ohm's law, and resistance, amperage, and you have the power here, amperage and voltage. That's all you need to know. These are just a little bit elaborate to connect those two laws together. So you don't have to remember that, but if you want to, it's fine. But the reason being is, if you notice, the resistance is not available in here. So at some point you might need to find the power using the resistance and voltage. So what I would do, for me to find the power here, I'll need to find the amperage and the voltage. If the voltage is missing, I can go solve for the voltage in this law, then plug it back in. Or you can do this shortcut. So the shortcut is there for you, but if it's confusing, use the two laws, find the voltage or the amperage using the Ohm's law, then you go back to the power law. Examples. If the voltage is 120 volts and the resistance is 5 ohms, what is the current? So I will use Ohm law, voltage, resistance, and amperage. What do I have? I have voltage, I have resistance, I need the current, which is amps. So A equals V over R. In this case, this will be 120 over 5, and that should give you, I think, 22 or something. Let's look. Yeah, 24 amps. And this is what you get from this division. Make sense? Okay, try it out. Let me know if it makes sense to you at all. If the voltage is 220 and the resistance 10, what is the current? Again, the same thing. You do the division, and it should come up to 220 over 10, which is 22. 24 amps. I should put 22. Sorry, this is 22 amps. Okay. One more. If the voltage is 110 and the current is 5 amps, what is the resistance? This time we're looking for the resistance. I'm going to change the pen. Looking for the resistance. So R equals voltage over amperage. And that will be 110 over 5. And that should give me 22 ohms. Mind the units, please. And use the two laws. More examples. If the voltage is 120 and resistance is 10, what is the power? Now we're using the power law. You see, power law is only available here. Power and voltage and amperage. So I'm trying to find the power. What is the power? Power equals voltage times amperage. So we multiply those two. 120 times 10, which is 1200 watts, which could be interpreted into 1.2 kilowatts if we divide by 1,000. So first you find the amperage. Hold on, what did I do? So power, volt and resistance, you have to find the amps first. Sorry, I did a mistake. So in this way, you have the amperage. You need the amperage, so you have the resistance and the volts. So for the power, it's going to be the same. So power equal voltage times amperage. Do I have the voltage? Yes. Do I have amperage? No. So I have to find amperage. Amperage could be found using Ohm's law, which is voltage over resistance times amperage. So in here, you'll see the amperage is volts over resistance. So you divide 120 over 10, you get 12 amps. You have your 12 amps, you plug it back into here, and you will say power equal voltage times resistance, and that will give you 1440 watts, which is 1.4 kilowatts. Kilowatts are more common. Okay, if the voltage is 220, the resistance is 20 ohms, what is the power? So we're going to repeat the same procedure. First we'll find the amperage using Ohm's law, then you find the power using the power law, and try to practice this a little bit. If the voltage is 110, the current is 5 amps, what is the power? So here we have the voltage, we have the current. Do we have all we need in power law to find the power? Yes, we have the amperage, we have the voltage, so we multiply them together and you get 5,500 watts. Okay, I'm just gonna leave it at that because I think that's very sufficient to understand how to use power law and Ohm's law, and there will be some practice problems and homework regarding these laws. It requires some practice, so try to get a pen and paper and do the calculation. So check Blackboard for more examples. I want to post also practice problems with the solution. I also would like you to look at the book. There's an example in the book at chapter 2, 2.9, talking about Ohm's law, few 1, 2, 3, 4 examples, and some examples about the power law. And I will go over the questions in the end of the book during the class. I hope that you will watch the video and will look at the other examples I have posted on Blackboard. Thank you very much and see you in the Hangout.